So in this lesson, we start to go through a different type of proof with coordinate geometry. So some basic steps to follow. Always plot your points first, draw the diagram, label anything that they give you. State the formulas you will be using. So actually write out the formula. So the slope formula is m equals y2 minus y1 over x2 minus x1. Write it down just like this before you start putting numbers in it. Make sure you show all of your work, all of the different steps, and then you have to sort of end this proof with a concluding sentence stating what you have shown and why it is true and proves what you are trying to do. Usually a theorem or just like a definition is enough to explain. So for example, if you're told to prove that two lines are parallel, you would then state and use the slope formula to show that the slopes are the same, right? So the work here is enough to have using the slope formula is enough to then state, because I found that the slopes of A, B, and C, D are the same, they are therefore parallel by the definition of slopes of parallel lines. Same thing with perpendicular, right? You use the slope formula to show that they are negative reciprocals. By the definition of perpendicular lines, they are perpendicular. So let's do an example. 4 points are plotted on the coordinate plane and prove that the lines A, B, and C, D are parallel. So we start by plotting our points. So A is -2, 0. B is 10, 3. C is 5, 7. And D is 1, 6. So we're trying to show that these two lines are parallel. So if they are parallel, they would have the same slope. So we first write the formula that we're going to use, which is the slope formula. And now I'm going to find the slopes. So first I'll do for AB. So our slope is going to be equal to y2 minus y1 over x2 minus x1. M is equal to 3 over 12, which simplifies to 1/4. Now we do the same thing for DC. So M is equal to 6 minus 7. Over 1 minus 5, which gives me -1 over -4, which simplifies to 1/4. So now we can see that the lines are parallel because they have the same slope. So we can say because the slopes of AB and CD are the same, the lines must be parallel by definition of slopes of parallel lines. So now here the vertices of the triangle PQR are plotted. Prove that PQ is perpendicular to QR. So here you're looking for a negative reciprocal, and we again are going to be looking at the slopes. So first thing you do is plot your points. So we start at -1, -1 for P, Q at 1, -2, R is at 3, 2. I don't know why there's a D there, so we can just get rid of that. So I'm going to plot my points. So I have my triangle. So we're trying to show that PQ is perpendicular to QR. So I'm looking at these two pieces. So I need to know the slope. So I'm doing slope formula. Of PQ. So for PQ, we'll do -2 minus -1 over 1 minus -1, which gives me -1 over 2. And then we do the same thing for QR. 2 minus -2 over 3 minus 1, which gives me 4 over 2, which is 2. And so now we can see that these two are negative reciprocals. So because the slopes of PQ and QR are negative reciprocals, the lines must be perpendicular by definition of slopes of perpendicular lines. Now, if you're trying to prove that two sides are congruent, you're going to use the distance formula to show that the distances are the same. So, for example, here, the coordinates of quadrilateral ABCD, and we want to prove that AD is congruent to BC. So let's first plot our points. We have -3, -1 for A, 0, 6 for B, 7, 3 for C, and 4, 4 for D. Plot something wrong. 0, 6, C, 7, 3. -3, -1. Wait, wrong. Let me hold on. So I'm just trying to see what the points should have been, so that way okay, so AD for -4. So that was my problem, is that D should be at 4, -4. For -4. There we go. That looks a lot better. So now, if I want to prove that AD is congruent to BC, we're going to be using the distance formula, which tells me x2 minus x1 squared plus y2 minus y1 squared. So we can start with AD. So we're doing our x's first. So 4 minus negative 3 squared plus negative 4 minus negative 1 squared. So that's going to give me 49 plus, that's going to be negative 3 plus 9, which is square root of 58. And now we're going to do the same thing for BC. So B, let's see, so we're doing the x's first. 0 minus 7 squared plus 6 minus 3 squared, which gives me 49 plus 9, which is square root of 58. So now I can say, and I'm running out of room, AD is congruent to BC because the distances are the same. So this is just a brief preview of how we're going to be writing our proofs for this unit.